Guys, what I have here is the powered automation systems of our TSU. TSU means TRO, sensor unit. We have here a 4 solenoid valve. This solid valve 1, 2, 3, and 4. So this solenoid valve have different functions. So once we do a ballasting from which we take water from the sea going to our ballast tank, the sample treated water must be taken while this solenoid valve 1 is energized. Okay? And once we do a ballasting, once this solid valve number 1 is energized, it will take water sample from this pipe outlet going to our pump, and then from this pump we'll bring the water on here going to our CLX number 1. Okay, here. So this CLX number 1 is used to have a reading while doing a ballasting treatment operation, and the CLX number 2 is not working. Okay, so normally, when this solid valve 1 is open within 60 seconds, it will bring and convey the water on here, pump inlet, going to the pump outlet, here, going to our CLX number 1. Then, after 60 seconds, this will close, okay? Once it is closed, this drain valve from our water pump will bring the water to drain, okay? While doing a ballasting operation, these 2 and 3 valve must be closed, okay? So the valve which is working only is the solenoid valve number 1 and the solenoid valve number 4 together. Alternately, this will open, this will close. When this is closed, this will open while the pump is continuously working, okay? To bring the treated water sample continuously to our CLX. Then when doing the ballasting from which we take water from our water tank going to overboard sea, the solenoid valve 1 will take a sample water going to our ballast treated water to take sample water from our ballast tank and bring this water on our pump, bring here and bring on our CLX number 1. And then alternately, when this is closed, this will open, it will drain the water out, and then when this close, the solenoid valve number 2, okay, this solenoid valve number 2 will open to take sample water overboard and bring the water from here going to our water pump and then bring on our CLX number 2. So alternatively, at first this measure the treated water from our ballast tank ranging from 3, 5, 10. This will measure the treated water from our overboard from which our TSU or which the ANU unit is working with to measure at least to 0.01 up to. So we are able to dispose the water from water tank ballast overboard sea, which was treated by our auto neutralization unit. So it is very important for us to understand how this piping system, solenoid valve 1, solenoid pump number 2, solenoid valve number 3 is being connected on our pipeline. So in here I have the air opening from which our built-in pump is working with, from which this must need to be open. Then this solid valve is on and off and take water sample from overboard going here, going here. So we must take note that this is from overboard and this pipeline is from water pipeline, which is being connected after the ECU or TRU unit before a water will be going in to our tank and before the water will be going out from the tank. So in general, this pipeline is responsible to give water on solenoid number 1, and this pipeline, as you can see here, there is Y connected going to our solenoid number 2 and going to solenoid number 3. So as I trace here in, the pipe is traced out from which we find it that this pipeline is going here and then goes directly there. So from here, it was goes here, going to this pipe, going to the solenoid valve number 1. So what I need to do here is just take a simulation. I will put 230 volts here to check if the water will coming out, because sometimes this solenoid valve is plugged. When this is choked or plugged, no water sample coming out, so we have a low TRO values because we do not take treated water once this solenoid valve is plugged. So as you can see here, I have this wire, and this wire have a number mark R003 with T003. This R003 and T003 wire going to my solenoid valve here has a mark here, R003, T003 on this relay holder going to the solenoid port number 2. So since this is going to the solenoid port number 2, it seems that somebody do interchange connection the solenoid port 2 to 1. So once they do like this, you must need to connect it properly. So this R003 T003 going to our solenoid port number 1 must need to put on the solenoid port number 2 here. So I will take and remove this, and I will put and corrected the position of the solenoid valve, because once you have wrong position of your solenoid valve, you put in place the 003, this port put on the solenoid port number 1, you are mistakenly operating your TSU unit. So it is very important for us, ETO, ETR on board ship, that you are able to trace out all the wiring connections, the piping connections of your solenoid valve and pipes, so you can get a correct operation of your TSU. Even engineers, chief engineer, second engineer, third engineer, fourth engineers, all engineers must need to be familiarized with this one. So I will put this another valve from solenoid valve number 2. I will bearing it on the solenoid port number 1 pipe to get a treated water during a ballasting operation. So now we do a correction. This T002, R002 for the solenoid valve 1 pipe number 1, from which our treated water sample for during ballasting operation is coming from after the ECU or PRU unit to take water sample of it to measure 3 to 5 up to 10 ppm value. And this R003 and this R004 is used during deballasting operation. So we confirm on top here. So we find here this R002, as you can see there, R002 is connected with T003 to supply 230 volts on our solenoid port 1. Okay, it is connected now, going to our solenoid valve 1, R002, T002. Now it is okay. Check also this port 2 solenoid going to R003, T003, from which a 230 volt supply are coming out to supply R003 here with solenoid port number 2, and then this solenoid port number 3 with R004, T004 be going on R004, T004 for solenoid port number 3. So we confirm that 1, 2, and 3 is okay now up to 4. Okay. This R005 for solenoid number 4 is going to our R005. This is R005 level for number 4. Okay, this is a drain valve. So now I just individually arrange the wiring in the solenoid valve 1 with T002, R002 for solenoid valve 1 going there. Port 1, 002, R002, T002 for solenoid 2, R003, T003 for here, R004, T004, and solenoid port number 4, R005, T005, and this will be seen here, R002, T002 for S1, R003, T003, S2, R004, T004 for S3, solenoid valve 3, R005, T005 for the drain. So everything now is corrected and checked. I'm going to check now if the water will coming out while I'm energizing the solenoid valve individually. So as you can see here, this no water, and this have small water coming here on our pump. We will check if will coming out the water to see if it's choke or plug. You must need to open the water source here. Okay, coming from our treated pipe ballast. This is our TRO sensor unit with XGT touchscreen panel. Normally, when you touch this one, you can interchange which solenoid valve is being open. But if this like this is stuck up, you must need to switch off the system to reboot it. Anyway, this is my PLC G7L CUEC programmable logic controller made by LS. And this one also have output signal 420 milliampere which is G7F ADHA PLC output input. And also we have here LS GLOFA G7M DR30U with open and close input, and here is the output. I'm going to switch off first this breaker. I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds. Then we will on again to reboot this. As you can see, now this will in the mode or the valve is closed, not activated. We will go in emergency, okay, and then press this to select which valve you must need to open. So I will select solenoid valve P1 here by pressing the F3 key. Okay, once you press this key, you can press this arrow going to the right to open. You see, now it is run with solenoid valve 3 is on. You see, we will check. I will put this relay on port 1, so we will check if it energized. Not energized. I will put this valve 2 to see who among them is energized. Not energized. I will put this relay on 3. Okay. And we will put this on solenoid valve number 4. As you can see here, relay 1, 2, 3, 4 is not energized, meaning this relay valve 1, 2, 3, 4 is also not energized. This we move. Both C and X, we run. This, running this, okay. I can put now the CNX1, okay. This will start. Once the CNX1 is started, the solid port number 4 is started, and the solenoid port 1 is started. So we will check if the water is coming out here. As you can see here, as I touch this one, have some water coming out. We will look. So as you can see here, the water is coming out once this solenoid valve is energized. Okay, means this valve is not black, it's okay. And this valve 1 is change its color from white color become black, means energized, because we run the CLX number 1 by putting a relay on it. So we verify now that we are able to activate the solenoid valve number 1 with R002, T002 with 224.9 volts. So the water will coming out, and we make sure that this water source are coming from our treated water. So this pipeline going to our pipeline going here and there. So we have pipe 1 and we have also pipe 2. I'm going to trace this if it is coming from the treated water after our PRU unit. Right from top, this is the pipeline going to our pipe from there, and then there, going here, okay, going there, and then going here, going with the filters, going here to take water sample. And these are the pipe, you see, the big pipe here, and this big pipe have pipe here, and this pipe will goes to our tank, and this pipe going to our overboard. See, overboard. So this is the reference sampling treated water from our PRU going on up. So you can see that. And from the pipe down, it was coming from here, and it was connected like this. So this is coming from our power rectifier unit to treat the water, and this is going to our bypass valve. Okay, so from our PRU unit, power rectifier unit 4321, it is connected there with the filter, and this valve going here. This is the valve, power treated water going here. So it was coming here, and this connection from our water balance pump 1 and 2. So when doing balancing operation, this bypass valve is closed, okay, to prevent water from ballast pump going directly to our ballast tank. So this is closed while this is open, and then to treat the water from there going to our PRO sampling pipe, which was connected on our TSU. So we must need to put here mark open during ballast operation. This one, okay? So it is verified also that this must be on, open, if we do a deballasting operation. So the water from here will goes here, then here to apply the solenoid valve 2 and 3. So now I will open this one, okay? You can see here, this is having a pressure of, you can increase. Then this is a solenoid valve was activated. The air coming here will goes here and here to drive this built-in pump. Supply water on our 2 and 3 valve. So to check again the solenoid port valve number 2, okay, we can switch on this one. As you can see, there is light on our PLC powering up. And then the valve 1 is now not energized. And then we can bring this into emergency. I'm going to select the valve number 2 by pressing the F3. Okay, now we have 1 and 2. So you can press the run, this one. Once you press the run, the CLX 1 and 2 must be energized. So from here 1, CLX 1, 2, CLX 2. I'm going to put the relay for the number 1. We will see once the relay CLX 1 is put. Okay, this is energized. The solenoid port number 4 and 1 together is energized. This is number 4. This is number 1 is energized. And then we can put also the number 2. Okay, this one. Okay. So we have both CLX1, CLX2. It is open now. It started in with solenoid valve 1 and 4 energized. 1 and 4. So this is our CLX number 1. As you can see, solenoid 1, solenoid 3. Okay. It means this is asking about solenoid 1 and 3. Okay. Take note that these CLX have their own solenoid also. From which solenoid 1 is intended for purge, intake. Here we have also one solenoid there inside. And also one solenoid valve going to our drain. So it is asking. Now I just disconnected it because I just checked. And on the CLX number 2, this one, we have also intake. Once intake is operated, this solenoid valve is energized. Must need to put water inside. Okay. And this water value means it needs water, but I don't open yet because I just checked the valve. So we will check it later. So as the process continuously, before we have solenoid for valve 1 and 4, and now the solenoid number 2 is energized. We will check. So I wanted to simulate the 2 and 3. So we can stop by pressing this one. If no stop and you cannot transfer the valve from which it is operated, you must need to switch off the system to reboot. This one, reboot, switch off, and then just switch on to reboot. Okay. Now we have here in remote, we can bring it into emergency. We can choose solenoid valve number 2. We can now run. Okay. So when run, this must be energized. Okay. Change from the color. And I just see here no water coming out. No water coming out here. And here I don't have 230 volts. I will check why. Even though here have valve 2 is energized, I will check this one why. And I verify here valve 2 is not energized, from which this is going to R22 T22. This R22 T22 having signal coming from the R22 and 222. This is. So I will check it later. I will put it on valve number 3 here. No possible to transfer from valve 1 to 3. I will switch off again to reboot, switch off, and then switch on. Okay. So here we can change from remote to emergency. We can select the valve number 3 by pressing F3. Okay. Both. This is number 3. We can press run. 1, 2, 3. Okay, energized. We will check. So confirm again. This valve number 3. Nothing. This valve number 4 is having 224 volts. That is a drain valve. Okay. continuously energized here. So guys, what I have here is the solenoid valve 1, 2, 3. I just trace out and find that this R002 and R003 was connected. They interchanged, so I connected it now. I put some electrical tips on it, and now I'm going to measure and check if this solenoid valve is not choked or not plugged. So to check this one, I just connected this R003 2 and 4, this one, and check this is connected here, R003, 002, 004. Directly connected on our solenoid valve 1, 2, 3, they have a relay here. So what I did is I just switched off the circuit breaker, and then normally open contact R002 with R32 before it was connected behind. So I just put in front for 1, for 2, 1, 2, 3, so we can check individually the solenoid valve if the water is coming out. So let's go, we will check. I'm going to switch on the breaker yet now, and then I will put this relay on the solenoid valve 1 and check if the water will come out. Okay, here. Okay. Okay. The water will come out. I will go and proceed on solenoid number 2. Very small water will come out. I will go on the solenoid number 3. As you will notice, the water on number 3 is very strong. Okay, to open now the water. Here, open. And here also open. Okay. I will put it again. Today on solenoid number 1. We'll check. I will check this one, open this one. Okay. Let's go. Okay. Okay. So this is open. We will change the valve 1 and 2. So guys, we already removed this one, and the other one is also removed. This is for the water ballast needed, and found this solenoid valve is stuck. Well, we are going to replace this one with a new one. Okay. So we remove all parts 1, 2, 3. We clean and check. Clean these parts and wash with water. We thoroughly clean it. After cleaning with the water to remove some sands and some solid particles inside, we will clean by air. Then we can swap each another to see how much water is coming out, because as I observed, the solenoid number 3 have more water coming out, but 1 and 2 have small water coming out. So I need to check and clean this solenoid valve. So to further check if this valve is blocked, I just interchange this 1 going to number 3, the 2 I put on the number 1, and the 3 I put on number 2. Okay. Then we will simulate if still the water coming out with become remain here 1 and 2 is remain small amount of water coming out, and number 3 having a big amount of water coming out. So we'll check. I will put another valve now. So this is solenoid void. I'm going to put it now on number 2, because this is number 2. Okay. Then this void on number 3. Okay. Check. At some meter now here. Okay. Then this one. Let's go. Okay. I will put. Okay. Good. Okay. Another here. So now I have the solenoid valve 1, 2, 3. I just interchange, and we will check if the water is coming out. Here changing its volume. Sorry. So before you observe that the solenoid valve number 3 has more water to come out. 1 and 2 small water coming out. So I just put the solenoid valve of number 2 to number 3, and number 3 to number 2. We will observe. Then after this one, I'm going to put the number 3, the number 1, and the number 1, and number 2. By doing this, we will know if the solenoid valve is not soaked or black or flat. Can we open this one? Okay. Okay, no water coming out. This is already open. We'll open the air. Okay, now it's open. Look, no water coming out. We are now going to put power on it. This breaker on. Okay. Then I will put this solid valve number 1 delay here. You can see, solid valve 1 no water. Okay. I will put on number 2 here. Oh, water coming out. Okay. Number 3. See? More bring more water. Number 2. More water. Number 1. No water. So verify that the pipe on number 1 drain pipe is flat. So I'm going to close this one. I will close this one. I will close this one. We will see what's going on inside.